Welcome back, everyone. Ready for another deep dive? Today, we're going to explore something you might not expect. We're talking about Mars, Earth, and, believe it or not, our planet's climate.
Mars?
Yeah, Mars. It turns out that rusty red planet and its gravity, well, it actually plays a role in shaping Earth's climate over millions of years.
Wow, that's fascinating. I never would have guessed that.
Right, so we got this article from Earth.com titled, Mars Gravity Pulls Earth Closer to the Sun, Warming Our Climate. And it leaves out some really wild stuff. Like, did you know that Mars's gravity actually pulls Earth a bit closer to the sun?
I did not.
Yeah, it's pretty crazy. And it gets even wilder. The article talks about these things called astronomical grand cycles, which I have to admit I'd never heard of before.
Hmm.
So what are astronomical grand cycles and why should we care about them?
Okay, so these cycles, well, they're basically recurring changes in Earth's deep sea currents, and they happen roughly every 2.4 million years.
2.4 million years. That's a long time.
It is. And these cycles matter because they actually leave a mark on the ocean floor. Scientists can see these cycles reflected in the sediment layers that build up over time.
So it's like the ocean floor is keeping a record of these cycles.
Exactly. These sediment layers are like a history book of Earth's climate. And by studying them, we can learn a lot about past climate conditions.
That's incredible. It's like the Earth is keeping a diary of its own climate history.
Pretty much. And what's really interesting is that the article talks about gaps in these sediment layers, like missing pages in that history book.
Oh, that's intriguing. What do scientists think caused those gaps?
Well, that's where Mars comes in. You see, even though Mars is millions of miles away, its gravity is strong enough to cause tiny changes in Earth's orbit, especially when the planets are closest together, which we call oppositions. Those oppositions happen every 26 months.
So every couple of years, we're basically lapping Mars.
Yeah, kind of. It's like Earth is passing Mars on a giant cosmic racetrack.
I like that visual. But how does that affect our climate here on Earth? I mean, are we talking about massive shifts in our orbit every 2 years?
Not exactly. It's much more subtle than that. These tiny gravitational nudges from Mars over very, very long periods, they start to influence Earth's orbital shape and tilt. And those shifts, even though they're small, they directly affect how much sunlight different parts of Earth receive, which leads to long-term climate patterns.
Okay, so Mars isn't yanking us closer to the sun every 2 years. It's more like this really, really slow tug that adds up over millions of years.
Exactly. Over those vast stretches of time, these little tugs can shift Earth's orbit enough to cause significant climate changes. And the research actually suggests that Mars's gravity pulls Earth slightly closer to the sun during these cycles.
Hmm. So being closer to the sun even a little bit, I'm guessing that would mean Earth receives more solar radiation. Wouldn't things heat up?
You got it. More solar radiation means a warmer climate.
And those warmer periods, influenced by Mars, are what scientists think caused those gaps in the sediment record on the ocean floor.
Yeah. Right. Think about it. Warmer climate, stronger ocean currents. Maybe those currents were so powerful during those warm periods that they swept away sediment that would have normally settled, creating those gaps.
Wait a minute, hold on. If Mars is making Earth warmer, doesn't that mean it's contributing to climate change right now? Are we blaming the wrong planet here?
That's a great question, and it's really important to be clear about this. The warming effect caused by Mars, it happens over incredibly long timescales, like millions of years. It's completely different from the rapid climate change that's happening now, which is driven by human activity.
Okay, that makes sense. So we can't point the finger at Mars for our current climate problems. Phew, I was starting to get worried there.
No worries. But it is fascinating to consider the long-term effects of Mars's pull on Earth. I mean, if it's been shaping our climate for millions of years, what can that tell us about Earth's past, maybe even its future? That's where things get really, really interesting. This research is adding a whole new layer of complexity to our understanding of Earth's climate history. It suggests that Mars's gravity has likely played a role in past climate changes, potentially even contributing to, say, the intensity of certain ice ages or warming periods.
So just to recap, we've got these astronomical grand cycles, driven in part by Mars, influencing Earth's climate over these incredibly vast timescales. And those cycles, they've left behind clues on the ocean floor, telling a story of climate change over millions of years.
It's like we've got this cosmic fingerprint that's revealing how interconnected our planet is with the movements of these celestial bodies. It really makes you wonder what other subtle cosmic forces are out there just waiting to be discovered.
Mind blown, and we're just getting started.
It is, isn't it? It's wild to think about.
So we've established that Mars has this like gravitational hold on Earth, and it's been kind of nudging us around for millions of years. But how does that actually like play out in our oceans? The article mentioned something called the AMOC, which sounds kind of important.
Oh, the AMOC is definitely important. It's the Atlantic Meridional Overturning Circulation, and it's this massive system of ocean currents that plays a crucial role in regulating Earth's climate.
So this ocean current, it's like a big deal for our weather patterns.
Huge. It's often described as like a giant conveyor belt that transports warm water from the tropics towards the poles and cold water back towards the equator.
So this ocean conveyor belt is keeping things in balance. And what's wild is that Mars might be helping to keep it going.
That's what the research suggests, yeah. The study found that these deep ocean eddies, those giant whirlpools caused by Mars's gravitational influence, they might actually help prevent the ocean from becoming completely stagnant, even if the AMC weakens.
Hold on, I need to like process this for a second. Why are scientists worried about the AMOC weakening in the first place?
Well, climate change is causing some significant disruptions to the AMOC. As global temperatures rise and glaciers melt, the influx of fresh water into the North Atlantic can disrupt the delicate balance of salinity and temperature that drives this massive current system.
So too much fresh water could like throw a wrench in the whole conveyor belt system. And if the AMOC weakens or collapses, what kind of impact would that have on us?
It could have really significant consequences for global weather patterns. Europe, for example, relies on the AMOC to bring warm water and moderate temperatures. A weakening AMC could lead to colder winters in Europe, and it could also disrupt weather patterns across the globe.
Got it. So a weakened AMOC is bad news. But these Mars-induced eddies, they could help prevent the ocean from going completely stagnant, even in like a worst-case scenario.
Exactly. It's kind of like a backup system almost. These eddies, they act like giant underwater mixers, churning the ocean depths and ensuring that some level of circulation continues, even if the AMOC slows down significantly.
That is so wild. I never would have thought that other planets could be, like, helping to keep our oceans alive.
It's pretty amazing when you think about it. It just shows you how interconnected everything is, even across vast distances.
So we've got Mars tugging at Earth, causing these subtle shifts in our orbit that influence climate over millions of years. And those orbital shifts, they create these deep ocean eddies that can be crucial for maintaining ocean circulation, even in the face of climate change.
It's a complex system, that's for sure. And this research highlights just how important it is to understand these astronomical cycles when we're trying to understand Earth's climate history.
Definitely. So let's talk more about these astronomical grand cycles. The article mentioned they happen every 2.4 million years. Can you like break down what's actually going on during these cycles? What's causing those orbital shifts in the first place?
Okay, so these cycles, they involve this really complex interplay of gravitational forces between Earth, Mars, and the other planets in our solar system. It's kind of like a cosmic dance where the planets' gravitational poles are constantly tugging and nudging each other, causing subtle shifts in their orbits over very long periods.
Okay, I'm trying to picture this cosmic dance in my head, and I'm already feeling kind of dizzy.
It's definitely a lot to wrap your head around, but one of the key factors that changes during these cycles is Earth's eccentricity.
Eccentricity, what does that mean exactly?
So eccentricity refers to how much Earth's orbit deviates from a perfect circle. A perfectly circular orbit would have an eccentricity of 0, but Earth's orbit, it's slightly elliptical, meaning it's kind of oval-shaped. So its eccentricity is greater than 0.
Okay, so Earth's orbit is a little bit wonky.
Yeah, you could say that. And these gravitational interactions with other planets, especially Mars, can cause Earth's eccentricity to change over time. Sometimes Earth's orbit becomes more elliptical, and sometimes it becomes less so.
And those changes in eccentricity, even if they're small, they affect our climate, right?
You bet. Think about it. When Earth's orbit is more elliptical, we experience bigger differences in our distance from the sun throughout the year. That means more extreme seasons, hotter summers when we're closer to the sun, and colder winters when we're farther away.
Wow, so even these tiny changes in Earth's orbit caused by the gravitational pull of planets millions of miles away can impact our seasons over long periods. It's kind of mind-blowing.
It is, isn't it? And it really underscores the fact that Earth is not isolated in space. We're constantly being influenced by the gravitational forces of other celestial bodies.
Definitely. It makes you wonder what other hidden connections are out there just waiting to be discovered. I mean, we've been studying our solar system for centuries, and we're still finding these incredible links between seemingly unrelated things.
I know, it's so exciting, and as our tools and techniques get more advanced, who knows what we'll discover next?
So to recap, Mars's gravity tugs at Earth, influencing our climate over these vast timescales. And those orbital shifts can also affect ocean currents, even potentially helping to keep our oceans alive.
And all of this points to the fact that Earth's climate is influenced by so many different factors, including these astronomical cycles that operate over incredibly long periods.
It sounds like we need to be thinking about these cosmic influences when we're trying to understand how Earth's climate has changed over time and how it might change in the future.
Absolutely. This research is just another piece of the puzzle, but it's a really important one. It highlights the importance of taking a long-term perspective and considering all of these different forces when we're studying our planet's past, present, and future.
It's pretty amazing to think that these celestial bodies, millions of miles away, have played such a big role in shaping the world we know today.
It's humbling, isn't it? It's a reminder that we're part of something much bigger than ourselves.
Well, this deep dive has certainly expanded my understanding of how Earth's climate works. We've covered a lot of ground, but there's one more fascinating aspect of this research I want to touch on before we wrap things up. We talked about how Earth, laps Mars every 26 months, and that creates those close approaches called oppositions. Does that, have anything to do with space exploration?
Oh, yeah, absolutely. Those oppositions are super important for planning missions to Mars. They provide the most efficient trajectory, and they help minimize travel time. Orbital mechanics, it dictates not only the path a spacecraft takes to Mars, but also the precise timing of launches to make sure it successfully reaches the red planet.
So it's almost like we're trying to catch Mars when it's passing by so we can get there quicker.
Exactly. It's all about timing and making the most of those planetary positions to make the journey as efficient as possible.
That makes a lot of sense. And understanding these orbital dynamics is essential for sending, well, everything to Mars, right? I mean, rovers, landers, eventually, maybe even humans.
Yeah. Oh, absolutely. Those precise calculations are crucial for mission planning, for sure. We need to be certain that the spacecraft arrives at Mars not only at the right time, but also the right location for a safe landing. Otherwise, well, you can imagine what might happen. We could miss the planet completely, or worse, end up on a crash course.
So it's like a cosmic dance, and we have to, perfectly choreograph every move.
That's a great way to put it. It's a delicate balance, The timing, the precision, understanding all those gravitational forces. Scientists, they have to map out these complex trajectories years in advance to make sure the mission is successful.
Wow. So not only does Mars's gravity influence Earth's climate over millions of years, but it also affects our ability to, get to Mars to explore it in the first place. Pretty incredible.
It really is. And it just goes to show, again, how interconnected our solar system truly is. And it really makes you appreciate the amazing work that scientists do, figuring out all these complexities and then using them to explore space.
Well, I have to say, this whole deep dive has been a real eye-opener. So let's recap what we've learned today. We started by talking about how Mars's gravity, even though it's subtle, can influence Earth's climate over incredibly long periods. It causes those shifts in our orbit, and it even affects ocean currents.
Right. And those shifts, they happen over millions of years. We call them astronomical grand cycles. And they've shaped Earth's history, and they'll continue to shape its future, too.
And then we talked about how understanding those same orbital mechanics is crucial if we want to successfully get to Mars, to send probes and rovers and, someday, maybe even humans.
Exactly. It's amazing to think that something like gravity, a force that we experience every day, can have such a profound impact on our planet and our ability to explore other worlds.
This deep dive has really left me with a sense of awe about our place in the universe. If Mars's gravity can influence our climate over such a long period, what other forces are out there that we haven't even discovered yet? What other connections are waiting to be uncovered? It's mind-blowing. Until next time, keep exploring, keep asking questions, and keep looking up at the stars.